polynomial functions of higher degree. Polynomial functions, first of all, you guys have studied these many times before, but they have continuous graphs with smooth, rounded turns and have no gaps, holes, breaks, or sharp turns. So for example, this is the polynomial. It's a nice, pretty curve as you move from the left to the right. This one right here, not a polynomial. What do we call this, by the way? When you get a V-shaped graph, does anybody remember what that's called?
Sharp.
Absolute value. Very good. This is called an absolute value. What did you say it was?
Sharp.
A sharp. This is a sharp graph. This is an absolute value, not a polynomial. This right here, not a polynomial. Why is it not a polynomial? Got a big old break in the graph. Yep, it's separated, so that's not a polynomial. All right, we're going to study what happens, though, when you do have a polynomial. So we have this thing called the leading coefficient test. Important information. The lead coefficient test says this. The degree, it says a couple of things. The degree of a polynomial is always the highest power of the polynomial. So for example, if you have this thing, 3x to the fourth plus 6x cubed minus 2x plus 1, the degree is the highest power. What's the highest power?
4.
4. So if you had me for, actually, whoever you had last year for Algebra 2, you studied this. We did this, in fact, a lot. In fact, I'm doing it right now in my Algebra 2 classes, and I feel like I dream about it at night. Not really, but. Okay, so we have a 4 there. So the degree is 4. Right here, the lead coefficient is this number right here. It's 3. The lead coefficient is the number that is in front of the term with the highest power. Okay? So since this is the highest power, this is the lead coefficient. Are you okay with that?
Mm-hmm.
Highest power is 4, lead coefficient is 3. All right. If the degree of the function is odd, put a big old star around this or something, or circle it, whatever, make a note of that in your notes. If the degree is odd, okay, if it's odd, there's two different situations. If the lead coefficient is positive, in this case right here, the lead coefficient was a positive 3. That tells you something. So in this case, if the lead coefficient is positive, the graph will fall to the left and it will rise to the right. It will fall left and it will rise right. This is how I remember it. Odd powers head in different directions. One heads left, one end heads right. How do you remember which end goes down and which one goes up? Well, if the lead coefficient is positive, I just know when I look at the graph from left to right, I have to be headed in a positive direction at the end of the graph. That is how I remember that. Okay, so down to the left, headed up as the graph is finishing. Positive meaning headed up as it's finishing. All right, if the lead coefficient, though, is negative, the graph is going to, the lead coefficient is negative, the graph will do exactly the opposite. The graph will rise left and it will fall right. So in other words, as I am finishing off the graph, in other words, as the tail here is ending, it is falling to the right because the lead coefficient is negative. So it will rise left, fall right. Important, this stuff right here is important. Those two things, and I think, if I'm not mistaken, I will get back to you on that, but I'm pretty sure I give you a cheat sheet for this part of the test. You don't have to remember all those tiny details. Okay?
Mm-hmm.
So make sure you have this in your notes somewhere, easy to access. So when we have to start doing some, you can just quickly look at your notes and see what you had to do. All right. If the degree is even, though, if the degree is even, this is how I always remember this. Parabolas. Everyone knows what a parabola looks like. And parabolas are even degree. Y equals x squared. Well, if it's an even degree, both ends are going to head up, or both ends might head down. So anytime you have an even power, 2, 4, 6, 8, 10, whatever the case is, both ends are going to head in the same direction. Does that make sense?
Mm-hmm.
So if the lead coefficient, now we're talking about the lead coefficient, if the lead coefficient is positive, the graph rises left and right. So if this number, the number in front of x squared, is a positive number, the graph is going to head up on both ends. But if the lead coefficient is negative, that one's a little bit easier to, this one, when the degree is even, it's a little bit easier to understand. If it's positive, they head up. If it's negative, they head down. Not a big deal. Okay? Example. All right, here we go. Negative 3x to the 5th power plus 4x squared plus x minus 3. All right, first of all, we need to figure out the degree. The degree is always the highest power. The degree is an odd number in this case. The degree is 5. I labeled it as being an odd number. You really don't care that it's 5 at this point. What you really care about is that it is an odd number. The lead coefficient. The lead coefficient is always the number in front of the term with the highest power. So we know it's degree 5. We look at the lead coefficient. The lead coefficient is negative 3. All right. Because the degree is odd and the lead coefficient is negative, that told us something. If you look back at your notes, it should tell you that the graph will rise left and it will fall right. So it will look something like this. We don't really know what's going on in the middle, but I know it's going to rise to the left. That means it's going to head down over here, and over on this side it's going to head up. Does that make sense? Okay, and we're going to talk more about some other things that we can figure out to figure out what's going on in the middle here, but for right now, this is what we know. Zeros of polynomial functions. This is when you need to be really good at algebra. You need to be able to factor things, which is part of your weaknesses. But you will get better as the year goes on. Zeros of polynomial functions. The first thing you need to say is this. Functions have at most n, and n meaning the degree of the polynomial. So if it is a 5th degree, the most number of zeros that it could have would be 5. 5 zeros. Are you with me there? If the degree was 10, how many zeros could it have? 10. Now, does it have to have 10? No, it could have as many as 10. Functions have at most n minus 1 maximum or minimums. So if you have degree 5, how many max or mins does it have? 4. It could have as many as 4 maximums or minimums. Probably important information. But now we need to work on finding the zeros. So, finding the zeros. X cubed minus 2x squared minus 35x equals 0. Right now, this right here would be very, very difficult to find the zeros. Sure, you could type it into y equals into your calculator. You could figure out where it crosses the x-axis by pressing a couple of buttons on your calculator, but I'm going to expect that you can show me all of the algebra steps, so we need to practice factoring. So we're going to look at these 3 terms, and we are going to decide what do they have in common. What do they all have? They all have an x. So I took the x out. You know what's going to happen? So I took an x out. Now, if I take an x out, that means I have to take an x out of every single one of those terms. So I'm going to go back to what we were talking about when we were completing the square. It's kind of like I'm dividing an x out of each one of those things. So if I divide an x out of x cubed, I am left with x to the power of 2. If I divide an x out of negative 2x squared, I am left with minus 2x. And then if I divide an x out of negative 35x, I'm left with a minus 35. Are you okay with that? Mm-hmm. So what we have now is, I'm going to delete this. It's not so messy. What I have now is, I still have this x up front, so I had to rewrite it. But then I had to look at this thing, because still I look at this and I'm like, I don't know what the zeros are. What are the zeros of x squared minus 2x minus 35? So now what I need to do is go back to, I don't know, maybe your freshman year when you learned to factor. You have to look for numbers that will multiply to give you a negative 35. And when you add them together, they get you negative 2. What numbers multiply to give you negative 35 and add together to give you negative 2? A negative 7 and a positive 5. Now my question to you is this. Can you see now why when I have it this original polynomial written like this, when I have it written like this, we know what the zeros are. I'm going to cover up the x minus 7 and the x. Just look at the x plus 5 part. What's the 0? Negative 5. Because if I put a negative 5 in for x here, I have negative 5 plus 5, which is 0. That's going to make this factor 0. So we say that the 0 is x equals negative 5. What about the x minus 7? What about this part right here? X minus 7. What about that? It's going to be 7, because if I put an x value of 7 in here, I have 7 minus 7. That gets me 0. So we have another 0 at 7. And then get used to this, you guys. Please, please, please make sure you're listening to this. When you have x all alone, what value of x could I put in for x to make it 0? 0. You get used to that, because that shows up a lot. When you have x all alone like that, don't forget that it's still a 0. Yeah, x is equal to 0. So when you write them as zeros, technically you would write them as 0, 0, 7, comma 0, and negative 5, 0. These are the values at which the polynomial crosses the x-axis. And when it crosses the x-axis, the y value is always 0. X squared minus 36. First of all, a couple things about this. You guys are honors level pre-calc students. You should be able to look at this and tell me right away what it is. And if you aren't there yet, you need to get there. X squared minus 36. First of all, x squared is a perfect square. Perfect square. Forgot how to spell perfect. All right, so is 36. 36 is also a perfect square. And whenever you are subtracting a perfect square minus a perfect square, whenever that happens, you need to right away recognize that it will factor to the square root of x squared, which is x, and then the square root of 36, which is 6. One of them is going to be a plus 6, the other one's going to be a minus 6. And if you don't believe me, I can show you the math. Do you want me to show you the math?
Yeah.
Yes? Okay. Yes. X plus 6 times x minus 6. Watch what happens. You multiply x times x, you get x squared. You multiply x times negative 6, you get negative 6x. Then you multiply 6 times x, you get a positive 6x. And then you multiply 6 times negative 6, you get negative 36. Negative 6x and a positive 6x cancel out. You're left with x squared minus 36. So that said, what if I have you do this? What if the problem you need to factor is x squared minus, say, 64? It would be x plus 8 and x minus 8. Those would be the factors. Get used to that. That's going to show up a lot. All right? What about this? What if I asked you to factor x squared plus 9? Does the rule apply?
Yeah.
Not when it's a plus. It only works when it is the difference of squares. Difference, difference, difference. Not going to work. In fact, x squared plus 9, not factorable. Okay? Say yes, Mrs. Corrigan.
Yes, Mrs. Corrigan.
You know what? X squared plus 9. Watch what happens. When you graph x squared plus 9, that's a parabola, common function x squared. It's a parabola plus 9. So it's a parabola shifted up 9 units. Does it ever cross the x-axis?
No.
No, it doesn't have zeros. Right on, Jacob?
So it has to be mine?
Has to be a minus, has to be a minus, has to be a minus. All right. So x squared minus 30 at 36 factors x plus 6, x minus 6. The factors then are negative 6 and positive 6. So you write it negative 6, 0, 6, 0. Yes?
Why are all the clocks off?
Because the government shut down so fast.
Oh, man.
That helps.
All right. 3x to the 4th power plus 6x cubed plus 3x squared equals 0. All right, so we have to look at our three terms. Our three terms, 3x to the 4th, 6x cubed, 3x squared. When you factor things, you have to take as much out of it as you can. So every single one of these terms, 3, 6, and 3, are all divisible by what number? They're all divisible by 3. So I take 3 out. And then this one is x to the 4th, x to the 3rd, x to the x squared. What can I take out of that? What do they all have? In terms of x's, they all have, an x squared. Yeah, so I take an x squared out. So really what I'm doing is dividing every single one of these terms by 3x squared. By 3x squared. And when I go back and do the math, here the 3's are going to cancel out. And then I have x to the 4th power divided by x squared. That leaves me with x squared. 6 divided by 3 gets me this 2 right here. X cubed divided by x squared just gets me an x. And then 3x squared divided by 3x squared is 1. So I have a 3x squared. Don't forget to bring that down with you. And that's going to give you a 0. And then this has to be factored. X squared plus 2x plus 1. You are looking for two numbers that multiply to give you a positive 1. And when you add them together, they get you a positive 2. Multiply to give you positive 1, add up to positive 2. That would be x plus 1 and x plus 1. Are you with me here?
Yeah.
All right, so we have 3x squared, x plus 1, x plus 1. What is the 0 of x plus 1? Negative 1. What about this 0? Negative 1. Okay, so this is what I want you to do. I want you to put a little note next to this. This is not in your notes. Please add it. X equals negative 1. Because it showed up 2 times, we say what, Richard?
I didn't hear the question. I was done.
When x plus 1 shows up twice, and we get an x value of negative 1, we say that it has a, do you remember this? We talked about this yesterday. We were having a conversation about it. That's why I thought maybe you were going to remember. It's okay if you don't remember. It's called a, this right here has a multiplicity.
Oh, yeah.
Oh yeah, that's right. Now I remember.
Yeah, no.
It has a multiplicity of 2. And we'll talk about what that means in just a minute. But for right now, multiplicity of 2. All right, now this, 3x squared, 3x squared. What's at 0? What's at 0 here, you guys?
Oh, 0.
0. If I put a 0 in, we have x alone. There's nothing being added or subtracted from it. It's just being squared. So that means we have 0. But the problem is this, is it's 3x squared. That means 0 shows up 2 times again. So that means you need to make another note here. Now we also have something called a
Multiplicity of 2.
Multiplicity of 2. And I'm going to start abbreviating multiplicity pretty soon because I'm not going to write that word out every single time I say it.
Too long.
Has a multiplicity of 2. Okay? All right, well the next thing we're going to talk about is repeated zeros. That's exactly what we just talked about with these multiplicities. 0 is a repeated 0, so it has a multiplicity of 2. What if that was a 3x cubed in this part right here? What if it was 3x cubed? What would the multiplicity be then?
3.
It'd be multiplicity of 3. Thank you, Marcus. Yes. All right. So, repeated zeros. If x minus a to the k power, where k is bigger than 1, I just have to qualify that we're talking about something bigger than 1, it is a factor, then the function has a repeated 0 at x equals a. So in other words, this is what's going on. We have x minus a. A is usually a number, so say it's x minus 2. We would say 2 is a 0. But if this k value is bigger than 1, like a 2 or a 3 or a 4 or a 5, then we have repeated zeros. And if we have repeated zeros, we have multiplicity. We'll talk about what that means in just a minute. All right, so please put a big star by this in your notes, but underline it or something. If the k value, in other words, if the power is odd, the graph is going to cross the x-axis at that a value. It will cross right on through it. But if if k is even, the graph is going to bounce. It's going to bounce, but it does not cross at that a value. Are you okay with that?
Yeah.
Yeah.
All right, let's see if you're okay with that. We'll try an example. I did one of them. I wrote one of them out for you, but then the next couple we're going to try together. All right. Example, x minus 5 squared times x plus 1. We have zeros. We have zeros where? We have zeros at 5. Would you agree? X minus 5 squared gives us 5. And then we also have a 0 at negative 1. Are any of them repeated?
Five.
The 5 is repeated. Very good. This thing right here. So I'm going to make a little note of that. What is its multiplicity? I'm going to start abbreviating. Multiplicity what? 2. Multiplicity is 2. And remember, just above in your notes, you wrote down that because it is a multiplicity of 2, which is even, what's going to happen at that x value on the x-axis? What does it say in your notes? Is it going to go right through the x-axis, or is it going to bounce? It's going to bounce, okay? This one right here, this has a it only shows up once. So its multiplicity has a multiplicity of 1. 1 is odd, and if it's odd, then it's going to cross right through. It is not going to bounce. Okay. Negative x cubed minus 5x squared. There's 3 steps that you need to follow in order to graph these things. And I've kind of laid the steps out for you. This is what you need to do. You need to check out the lead coefficient, first of all. Do the lead coefficient test. And that means that you need to check 2 things. You need to check out the lead coefficient, but you also need to check out the degree. All right, so the lead coefficient. Look at the lead coefficient. That's this number right here. Is it positive or negative?
Negative.
Negative. It's a negative x cubed. Therefore, I wrote down as negative, and you're probably going to want to write that stuff out when you're working on these by yourself. The degree. The degree is the highest power. What is the highest power? It's 3, which is odd. Now, if you look back, if the lead coefficient is negative and the degree is odd, that tells you that it's going to rise left and it's going to fall right. Again, you should have that information right in front of you when you're working on these. Okay? The next thing you need to do is calculate the zeros. All right, so we have negative x, here's our original function. We have negative x cubed minus 5x squared. What can I factor out of this so I can find the zeros a little bit quicker? What can I factor out? They all have an x squared. And if you can get rid of a negative out front, get rid of the negative. Factor the negative right out. So I factored out a negative x squared. And when I factor out a negative x squared, remember that means I'm dividing everything by negative x squared. The negatives cancel out in this case. I have x cubed over x squared, leaving me with just an x. And then the negative 5 divided by the negative 1, they cancel to give us 5, and then the x squareds cancel out also, so I'm just left with x plus 5. So the zeros. Look at this, negative x squared. X is equal to 0. You with me here? But notice here I wrote that it's even multiplicity. Even multiplicity because it's squared. 2 is an even number, has even multiplicity. If it's x plus 5, the 0 is negative 5, which is
Odd.
odd multiplicity. Graph it. All right, we already know that it's going to rise on the left side. It's going to fall on the left side. So let me show you what I did. I went to my zeros. I knew I had a 0 at 0 and I had one at negative 5. So I put a point at 0 and I put a point at negative 5. And I knew that it was going to rise on the left side. So from the leftmost 0, I made it rise up. And then from the rightmost 0, I made it fall down. But then I also knew because 0 is an even multiplicity, I knew that at 0, it wasn't going to go right through the x-axis. It was going to hit the x-axis and then turn right back around. It like bounces off of it. You understand what I mean by that? It keeps going. -5 had an odd multiplicity, so at -5 it goes right through the x-axis. Now, is this exactly what the graph looks like? Maybe not exactly what it looks like, but it sure is a pretty good idea. This thing right here might dip down a little bit more, but we have the general form of the graph now.
Yes.
Okay? Let's try one.
-5.
You should have these examples laid out in your notes right now. Lead coefficient test tells us to check two things. What two things do we need to check?
The coefficient degree, what are you talking about?
You have to check the lead coefficient. Lead coefficient is, we don't really care that it's 3. What do we care about?
Odd.
It's positive.
Oh,
We care that it's positive.
yeah, positive. My bad.
We also need to check out the degree. What is the degree?
Even.
The degree is 4. Now, if the degree is 4, what we really care about really is that it's
Even.
So we have positive and even. So if you look back in your notes, that's going to tell us something. If the lead coefficient is positive and the degree is even, that tells us that it will do what?
Rise to the right.
Rise to the right and rise to the left. In other words, both ends are up. Both ends up. Now, it certainly might be a parabola, but with this fourth power, we might have some other turns and stuff in the middle. But both ends are going to go up. Is it okay if I write here both ends up?
Yep.
Instead of saying rise left, rise right, both ends go up. We got to find the zeros now. The zeros. So I'm going to write out my function 3x to the 4th minus 48x squared. What do they have in common? What is the biggest number that I can factor out of 3 and 48? I can't factor out a 2. I can factor out a 3. And then we have x to the 4th and x squared. How many x's can I take out then? You can take out an x squared. So we have 3x squared. So I'm going to divide a 3x squared out of both of these terms. All right, which is going to leave me with, now these 3's cancel out. So what power of x do I have left? X squared, very good, minus, and then 48 divided by 3 is 16. You guys, we just talked about that a little bit ago. The x squareds cancel out. So really what we have going on here is 3x squared. What does this do? X plus 4 and x minus 4. So our zeros. What are our zeros? We have a -4, a +4. What about this thing though? 3x squared. 0. Very good. So we have 0. And I'm going to make a note here. Is that even or odd multiplicity? Power of 2. So we have even multiplicity. And we know that if it's even multiplicity, it's going to bounce, not cross. This right here is -4. So we have zeros at 0. We have one at -4. Even or odd multiplicity? This right here, x plus 4 means -4. It only happens once. It's x plus 4 to the first power. So it's odd multiplicity. And then what about this x minus 4?
Same.
It's +4, odd multiplicity. All right, so when you graph this, graph your zeros. Put dots wherever you have a 0. So I'm going to put a dot here at 0. I'm going to go over here to the left to -4. I'm going to go over here to the right at +4. So I have a -4, 0, and 4. I know both ends go up. Would you agree?
Yeah.
Hopefully, because we said that. So I go to my leftmost 0, I head up. Go to your rightmost 0, head up. -4 had an odd multiplicity. What does that mean? It goes right through. Yeah, so I I'm not gonna head back up right here, I have to go through it. And then once I get down here, I know I need to go back up to my 0 at 0. So now I'm gonna turn back up again. It's gonna bounce at 0. It's gonna head back down again. And then what's gonna happen at 4?
Gonna go
It's gonna go right. Is it perfect?
Yes.
It's a W.
Well, it is my graph, so. Alright, one more example and then I'm gonna shut up and you guys can try some by yourself. Alright, look, we don't even have to do any factoring here, that's nice. There we go, lead coefficient test. Lead coefficient, positive or negative?
Positive.
Yeah, we have a 1x squared. Now be careful with these, because really you have a 1x squared that's going to have to be multiplied by a 1. 1 times 1 is 1, so it's positive. The lead coefficient is going to be a positive number. What about the degree? Is it even or odd?
Even.
It's
Okay, be careful, because this is squared, and it's going to be multiplied by an x. So when you multiply x squared by x to the first power, you're going to get x to the
third.
third power. So the degree
It's odd.
is 3, which is odd. What does it tell you if the degree is odd and the lead coefficient is positive? What does that mean?
It will rise right.
It's going to fall to the left, and it's going to rise to the
Right.
right. Fall left, rise right. Zeros. So we've got x squared, and then we have x minus 4. What is this thing right here? What is that 0? X squared? What value of x could I put in for this to get me 0? Yeah, 0. Even or odd multiplicity? Even multiplicity. What about this one? Positive 4, even or odd? Odd. Yeah, only shows up once. So it is odd multiplicity. Plot your zeros. You've got one at 0. You've got one at positive 4. 0 and 4. Alright, we know that the graph is going to fall on the left side. It's going to rise on the right side. So go to your leftmost 0, head down. Go to your rightmost 0 and
Go up.
head up. This one has an even multiplicity. 0 has an even multiplicity. So at 0, what do? You're going to bounce. So that means you have to head back down. It bounces. But if it's odd multiplicity, it's actually going to cross right through. So after you head down, you need, you know you're going to have to curve back up and cross right through.